Alright, so we're going to look at the three types of problems we see with optimization. The first is an abstract problem which has no context. So that could be something where I'm just giving you an equation and saying what is the maximum or the minimum of this equation. Or find the minimum of this equation. How do we go about finding the minimum of this equation? Derive it. Why do we derive it? I want to find out when my derivative equals 0. I derive y with respect to x and I get negative 4x plus 4. I'm hoping we all know how to derive. Now that step there, you might be asked to use the chain rule, you might be asked to use the quotient rule, you might be asked to use the product rule. You could be asked to do a whole number of things that we've already learned. Now I'm going to let that equal what?
0.
And I want that to equal 0 because I'm looking for what?
Tangent.
I want my tangent to equal 0 because I want the? Yeah? I want the turning point. Now there's basically, with turning points they can look like this, they can look like this. There's also another turning point called a point of inflection that looks like this. Is a point of inflection any value to us?
Yes.
If we're looking for a maximum or a minimum, is that type of turning point any good to us? No? So we really are hoping to find a turning point which looks like a U or an N. So we let that equal 0. 0 equals 4x, negative 4x plus 4. 4x plus 4. Sorry, 4x equals 4. X equals. Now if I was to ask us to prove that it is a minimum, what would we do? So I've got two options to prove. Okay, so I can go d dy dx, which is the double derivative. Okay, what's the double derivative of negative 4x plus 4? Negative 4.
That is a maximum. That is not a maximum? No.
Yep. Does that make sense? Would you expect that to be a maximum?
Yeah.
Sorry, I said minimum at the start, and I said minimum at the start. I forgot I put the negative at the front.
So it's the opposite, isn't it? So it's the opposite. Like
Yeah.
it's positive.
Yep. That sort of makes sense. Okay, if we... The other choice is we do up the table. So choice 1 is that. Choice 2 is we have d dy dx versus, what's the other axis? What's the other part of the table?
The tangent is like 1 below.
So am I throwing in y or am I throwing in x as the other part of the table? X. Okay. At 1, what is my derivative?
0.
So then I can sub in 0, sorry, and 2. Yep, 0 and 2. What is negative 4 times 0?
0.
Plus 4? So that's 4. I don't really care, I just want to know that it's positive. And what about negative 4 times 2 plus 4 is? Negative 4. Again, I just want to know that it is negative.
Will they always be the opposite? Like if you found the first one, I will always be the opposite.
Unless it's a point of inflection that looks like this.
What do you
In
do
which
then?
case it'd be positive then positive.
What, because it's not a positive before?
Well, if you've got positive then positive, it's going to be a point of inflection. Is that the maximum or the minimum?
No.
Or is that just a point in your graph? So it's no good to us as a max or a min.
But didn't you say those don't matter?
They don't matter as far as turning points for max and min.
So the proof to the word to maximum is that A.
So we've got that, that, therefore we have a maximum. Now, is that the only way, or in that function, that would be the maximum, correct? If that was a cubic function, what's a cubic function look like? Yep, so it might look something like this in the blue. That could be what a cubic function looks like. What's the max and the min of that function? Wouldn't the minimum be negative infinity? Wouldn't the maximum be positive infinity? So the only way you would find a max or a min in that function is if I gave you a domain, for example. So if I gave you that domain, that might be the max. Is that the only place that could be the maximum?
No.
I'd have to also test that point there, wouldn't I?
It's like the bigger one.
Yeah, whichever one's larger is the maximum value, correct?
So that means you sub in x to those points.
You'd sub in a value for x into which function? Y, dy dx, or dy or d dy dx? I would sub that value and that value into my original function. Y? Into my y function, sorry, that's a fair point. Into my y function. Because I want to know which one's higher, don't I? Does the tangent of the function tell me which one's higher? No, but the actual value that I get out of my y will tell me which value is bigger, won't it? Happy with that? So that's the first context. Just simply derive, let it equal 0, solve for our tangent and prove that it's a max or a min. The second option is what we've been looking at in 11.2, and it uses a word that starts with G. Close. So the second type of problem.
What's the second one?
Geometric. Now these problems are a little bit different. Why? We've found them harder.
Because you have to make your own life equation. What the shape is.
What's the skill we have to use? What's the process that we often use? We often get given a perimeter or an area and we have to find the max or the min area or volume, for example. What's the skill we often use? Yeah, so we often have to make a rule and use substitution. And we use substitution when we have how many equations? 2 equations and how many variables? 2 equations, 2 variables. So you just need to use some of those baseline skills that we've learnt over the course of our maths career. That's not the only thing that makes these problems hard. What else makes them a little bit challenging? Knowing your shapes, knowing your perimeter area rules. What else? So that is difficult, that is challenging, knowing your rules off by heart and being able to recall them at the right. I find one of the most challenging things in these problems is contextualising or to getting an understanding of what they're asking. Happy with that? And that can be very difficult. So what's the best way to help yourself get an understanding of what they're asking in the question usually? Draw a picture. Give yourself a visual aid. Herein lies why you've all got a piece of paper. What I want you to do with your scissors is cut out corners, square corners. What's a square mean? When I say the word square, what do you know about a square? All the same size. You have to cut out 4 equal size squares, not like mine because I haven't used a ruler. You're going to cut those out in a much more accurate way than I am. Yep, in the corners. And when you do that, you should be able to fold your piece of paper up into a prism. A prism. And all I'm asking you to do right now is to make the biggest prism you can possibly make. Make it carry the most liquid or the most volume.
So we have to do so smaller.
You decide what makes the biggest volume. I don't care. You decide what you think makes the biggest volume.
Less or more?
You decide. It's up to you. Are we clear? So cut your corners. 4 corners of equal size. You're going to fold them up. I want the biggest volume you could possibly get. Jack's gone about it really precisely. He's already started cutting without using his ruler, which is really good. You probably want to measure the length of the sides that you're cutting. Okay?
Less surface area.
I want max volume. I don't care about surface area. Surface area will be
Yeah, but if you feel like a wild guy, you can have less.
surface area.